Okay, open up to 9.2, please. Okay, so it's page 379. Now, yesterday we were graphing lines and inequalities using lines. The quadratics work a little bit differently than the line. The line you only have two sides to shade on, but within a quadratic, there are two distinct possibilities as to what happens. So if I take a parabola that works like this, I have two places in which I can shade. These coordinates are zeros, x-intercepts, are important to find out whether or not I got a shade inside or outside of them. So one of my possibilities is shading in here. That's one of the possibilities. The second possibility is shading outside here, like that. Okay, so those are the two distinct possibilities. Now, they could include this, they can not include it, in which they have an open dot. Those are also important for us to see. So what we do is we work with the x-axis and the intercepts to find out whether or not I have to shade between them or on one side or the other. So it actually works out fairly easily to do such a thing. Okay? So let's open up and I'll show you how this works. We've got x squared plus x greater than 6. Okay. So the first thing that I need to do, here is I'm going to change this to an equals to, and I'm going to solve it like I solve all my quadratics, hopefully by factoring. X squared plus x minus 6 equals 0. X plus 3, x subtract 2 equals 0. X is equal to negative 3 and 2. Okay? So that we've done loads and loads and loads of this, right? Nothing new to us. So now what we need to do then is we're going to draw ourselves a little number line like this. And when we did okay, so first thing I'm going to do, the open dot versus closed dot is also the same as the dashed line versus the solid line on a line. So in this case, there's no equals to, which means then that my two intercepts both have open dots. So that's pretty straightforward. Now I'm going to do the exact same thing that I did when it came to shading, where I would substitute a coordinate in and see whether or not the statement was true. In this case, I only need to substitute a number in. So I'm going to start right here. I'm going to put negative 4 in. And if negative 4 works and makes that statement true, I just put a check mark beside it. So let's put it in there. Negative 4 squared is 16. 16 subtract 4 is 12. Is 12 greater than 6? 12 greater than 6? Yeah. So I'm going to put a check mark out here. Okay? Now I'm going to pick a number between negative 3 and 2. I'm going to use 0. 0, 0. 0 greater than 6? No. Okay? And then finally I'm going to pick a number on the other side. I'm going to use 3. 3 squared is 9. 9 plus 3 is 12. 12 greater than 6? Yes. All right. So now I need to graph this equation. All right? and shade. And again, okay, so 1, 2, it's an open dot, 1, 2, 3, be an open dot if need be, okay. I should find out what my intercept is, or sorry, my vertex is. I'm just going to make sure I go through this properly. Doesn't say anything about technology, so I'm going to do it. Okay, my x-intercept is halfway between these two values, between -3 and 2. Okay, so what's halfway between -3 and 2? -0.5. So I'm going to substitute that into my equation. So I have y equals x squared plus x minus 6 equals -1/2 squared plus -1/2 subtract 6. Okay? So I've got a quarter, subtract a half. It's a quarter, subtract a half. -1/4. And then subtract 6, so that'd be -6 1/4. So 1, 2, 3, 4, 5, 6, somewhere down here, approximately right here. There's my vertex. So my vertex would be -1/2 and that. So now I draw a dotted line, and where did it say to shade? Do I shade in the middle? No, I shade on the outside. Just like that. Okay. Let's take out your Desmos right now. Use Desmos. And I want you to graph the equation as it's originally written. So x squared plus x greater than 6. And make sure that we've got all of this down. Okay. X greater than 6. Et voila. Okay? Now, what's the problem with this? It's not a problem, is it? Okay? So we have to somehow get this so we can turn this into a problem. We've got to write this as an equation. So right now, as written, this is all we had to find. We didn't have to graph the actual parabola. All they want you to do in example 1 and example 2 is just find out which side I'm going to shade. Okay? So until they give you a y equals, which is in 9.3, all you're doing is finding your roots using factoring, using test points on the outside, the inside, and the outside, and just find out what your domain is for that. So in this case, my actual solution for this, if I didn't need to draw the parabola, my solution would be x is less than -3, x such that, should get the notation down, x is greater than 2, and it's good practice to put in x as an element of all reals. So there's your solution for this. X is going to be less than negative 3, X can be greater than 2, and X and L variables. Okay? Questions so far? Alright, let's have a look at the second one, and then if you have questions, that's where it'll end up being. Alright? 2x squared plus 5x is less than or equal to 3. 2x squared plus 5x less than or equal to 3. 2x squared plus 5x subtract 3 is equal to 0. I'm going to factor this. I'm going to do the fast way of factoring. Like that. Okay? 2x squared only has two factors, 2x and 1. 3 only has two factors, 1 and 3. And somehow you need to have it so that it's 6, so that you can subtract and make 5x as your middle one. So what are my two roots? -3 and 1/2. Okay, so let's draw ourselves a number line now. 0 right there. -3, 4, 1. Doesn't matter, that's all I need right there. So I'm going to put my there. That's 1/2, right? That. Okay. So far so good. So now I just plug in. Take the -4, put it in here. What's -4 squared? 16 times 2? 32. 32 subtract 10. Or sorry, 20. 12. Is 12 less than 3? No. So put an X here. Let's put 0 in there. Is 0 less than or equal to 3? Yeah. So it's right there. Let's put a 1 in there. 2 plus 5 is 7. 7 less than 3? No. So where am I shading? And you're done. Yes, Rex.
Will you ever get a parabola where you'll have to shade in between the vertex and the x-axis?
No.
No?
Well, if it's inside the parabola, yes. Yes, but you won't shade like down here in between.
No, like just
Like-
in
Like once you've got this here established, there will be no shading in here. But if the shade is inside these, then yes, they'll shade all the way in there. Okay? Yes, Brennan?
Like for that, wouldn't you really have to only check one then? In that case?
Well,
Like,
it's,
if you try -4, if it's not, then it's shading inside the parabola, and
well, no, not necessarily. It can, an equation can only work with one area. There is a possibility that that can happen. So you do have to check all three areas. In theory, you're right.
So-
You think that if it doesn't work on this side, it probably doesn't work on the other side because you're using a quadratic, right?
yeah,
So then it has to only be the middle.
Yeah.
But you want to check, well, you got to check 2 out of 3 for sure, but you should check all 3.
so like, would there be a question where, say, the middle wouldn't be it, the left side wouldn't be it, but the right side would be?
That's what I was saying.
Yeah.
There's a possibility, but I don't know if I've seen that.
Okay.
We just have to go through them and see, but yeah. All right, that's her. That's all there is to this. So basically you're still shading lines. You're just now using the roots by factoring to solve for it. Okay? Any questions about it? I know it's fresh. Probably isn't. All right, I'm just going to shut the camera off and I'll answer questions from 9.1 if you have them.